Good afternoon, everyone. Thank you for having me here. I was initially told that there was going to be 2 speakers, and I was given 20 to 30 minutes time slot, so you'll be getting home early today. I assume no one has anything against that. So my name is Iiro Vanne, and I've been asked to talk something about my path to Ann Arbor. And I'm going to start by discussing a bit where I'm from, and then going to go through my educational background, how work ties into that, and how COVID changed a lot of things for me as well as for other people. And then I'm going to discuss a bit more about what I currently do at work and what my PhD is all about, and then the final steps of actually getting here. So it's going to be a journey of some 10 years and how that led me coming here. So I'm from Finland, pretty much similar climate than here, a bit more cold, a bit more miserable. I'm from Turku, which is right here, about 100 miles from Helsinki. So we are on a coastal city, and that shows quite heavily. We got a lot of maritime industry in Turku. For example, the shipyard where I work at, and some few thousand small companies that support the shipyard work and have their own business, of course, as well. We have a population of some 190,000 people. So it's a bit bigger city than Ann Arbor, but I think Turku is a bit larger on the surface area side. So the center is pretty much the same as here. So it's kind of homey here. So education. I graduated from high school in 2010. I did terrible. My grades were absolutely awful. And I went to Army. Everyone in Finland, every man goes to Army. I spent a year there. And at the end of Army, after that, I did some odd jobs. I was a bartender for a while, fixed and sold the bikes. And at some point, I realized that I would like to have some real profession and wanted to do something else with my life. But then I realized my high school grades were so terrible that I did not have a possibility to apply to universities or University of Applied Sciences. And I needed to actually go back to the high school and raise some grades. And even after that, I could not apply to university with those grades. So I applied to Turku University of Applied Sciences, which is the mask is annoying. University of Applied Sciences is kind of a lesser school than university. The teaching is towards more practical applications and not as theoretical as it is in universities. And you can only study to the bachelor level there. And I graduated as an engineer. First 2 years, I studied general engineering under mechanical engineering department. And after that, it was time to specialize into some field. And for me, marine technology was the most interesting one available. So that's where I went. And funny thing happened, I had internal motivation when I went to the Turku University of Applied Sciences. And that carried me through well. I actually did pretty well there. And in Finland, if you do well enough in University of Applied Sciences, you have a possibility to apply directly to actual university, to the master's phase. So that's what I did. I applied to all the university, got accepted there. Again, you need to apply to the mechanical engineering, but you start studying marine technology directly. And I graduated from there in 2 years. And I had slight marine safety focus on my studies already back then, did some fire safety courses and such, and we're gonna get back into that later on. And I started the PhD in 21, but let's get back that to later. And there is something actually in this picture that's on the screen. You see these colorful overalls. They're huge baggy overalls that in Finland pretty much every student gets when they start their studies. Each department has their own, like mechanical engineering. This is the ones I had, these purple ones. And like law and economics, everyone has their own color that they use. And these are mainly used in student parties, student events, etc. And from every event or party or task you do, you get a patch like this. And you then sew those patches into your overalls. And the more patches you have, the cooler guy you kind of are. It's pretty insane. Like you can have layers of patches. That's crazy. But what's actually cool about the overalls is there's like unwritten rule that they are whole free pass from being complete idiot in public. You can get drunk, you can do anything, and no one's gonna actually judge you. They kind of know you're a student and you're living your life. That's kind of cool. I wonder if you have anything similar here in the US. And this is a logo of Laivanrakentajan Kerho, which is Shipbuilders Club from Aalto University. So it's student organization. They're really active and they have international and national excursions, a lot of company visits and such. So if you have some student organization for shipbuilders, etc., I strongly suggest you to contact them and see if you could organize something together. You can ask details from me later on if you are interested. So I'm gonna skip my working life before I started to study at the University of Applied Sciences. It's gonna be boring, but first summer job I got when I studied the mechanical engineering was at KM Invest as a welder/machinist. I had some machining background, so I was quite happy to do something in the industry already. The main product I made was this kind of pipe cleaning tools. So it has a the front part and chains where we have hard metal pieces attached to it. That's going to be attached into the end of a rod, which is going to be attached into a wire. And that is used to clean up plumbing pipes in buildings before you insert epoxy resin sock inside the plumbing. And that basically extends the service life of the plumbing system with 20 to 30 years. So those are kind of needed a lot with our Finnish old building infrastructure. So that was cool. Next summer, I already knew that I'm gonna apply to the marine technology sector in school. So I was super lucky to get a summer job in the industry of marine technology. And I got a summer job from ILS Oy, which is an engineering office specialized in ice-breaking ships and icebreakers. And it was really awesome experience. I worked there later on as well, as you're gonna learn. But the small office, you get to do a lot of things. I did ice strengthening calculations. I attended inclination tests of real ships. I did model ice scale tests. I designed exhaust arrangements. I designed a mast, all sorts of stuff that you actually don't get to do that large variety of things when you work in bigger company. They have, of course, their benefits as well. But here in the picture, you see Nordica, which is quite special icebreaker. It is one of the second two multi-purpose icebreakers, the first ones. And the multi-purpose means that traditionally icebreakers cannot operate in open water. The hull form basically causes too high accelerations in rough weathers. Finland has some really old icebreakers that are like that. They just stay on the pier for the whole summer. They cannot operate in open water. But these could, and the hull form that enabled the multi-purpose operation, this is a standard. Nowadays, every icebreaker is some sort of multi-purpose. The hull form was developed at ILS Oy, and they take real big pride on that. And I actually was able to visit that ship during Aalto University's winter navigation course. We spent a week on board that during winter when it was operating. That was really cool. After that, during school year, I did a short gig with Almaco. Our head teacher at the University of Applied Sciences used to work for Almaco. So every now and then he got a message from them that they would have some easy job that our teacher could offer to students. And so I took on one of those. I spent 3 weeks on Anthem of the Seas, sailing around Caribbean. And I was logistical assistant / fire guard. Really, I was a fire guard. Logistical assistant was there mainly so that it would look a bit better in a resume. But it was a cool gig. We renovated, it was a new ship, but they needed more crew on board. So we renovated one crew training room into crew cabins. But I got to see the ship operation in real life and the beautiful scenery of Caribbean. That was cool. And then I spent another 3 weeks on its sister vessel, which sailed between China, Korea, and Japan. We did the same thing there. If you have possibility to visit ships, like do some short work there, I strongly suggest it's really interesting. And food is good. And I utilize the studying years and the summers to basically map out a bit what kind of possibilities there are in the industry. And on the third year, the summer, I applied and got accepted to Wärtsilä Oy's Research and Development Department. And Wärtsilä is the world leading provider of large four-stroke engines. And the picture here shows Wärtsilä 31, which was the hot new topic at the time I was working there. It was the most efficient four-stroke engine ever built, had dual fuel capabilities and all that coolness. And I still, after that summer, decided that ships are more cool than engines. So I went back to ILS to work part-time for the rest of my studies and full-time after I graduated from the University of Applied Sciences. And here in the picture, there's actually a really cool product. I was part of designing this. It is a removable icebreaking bow with a self-propulsion. So basically, you take a normal tug, attach some hydraulic attachment points to it, and attach the independent icebreaking bow, and now you have icebreaking tug. And it operates on one large lake in Finland and keeps it open for other ships to operate during winter. Cool stuff. And then 2018, I transferred to Meyer Turku, which is Kevin's words, the most sophisticated cruise ship yard in the world. Someone might argue that Italians and French are kind of proud, but anyway, did my master's thesis there, and after that I continued as a naval architect in ship safety and statutory team. The safety and statutory, it's not the occupational safety of the shipyard or the board. We are responsible for producing evacuation plans, safety plans, safe area plans, and all the classification society and flag state contacts, alternative design, special safety studies, etc. So it's a lot more politics than it really is of engineering. It's insane how political these things are. And over there you can see one recently delivered cruise ship. And then came coronavirus, which was really bad thing for the cruise ship industry. I think Royal Caribbean's and Carnival's stock prices plunged some 85 to 90% at the worst time. So that tells a rough tale. And they suspended operations for what year and a half, pretty much, and they are still not fully back on. And that caused, we were lucky at the shipyard that we had a really good order book that was full until 24. Some ships already for 25, but no one canceled any orders, but we need to extend the order book so that now the ship that was supposed to be delivered on 25 is going to be delivered on 26. So we had ramp-up plans at the shipyard. Those needed to be halted, and cooperation negotiations were started. Some people were laid off, but at the same time, my professor approached me. He had tried to get me make PhD for 2 years, but now he made pretty good offer, and the time was kind of right for that. So I was also able to modify my role at the shipyard to start doing only like fire safety analysis and detach from the daily dealings of the position. And the PhD that I'm doing, it's joint venture between the shipyard and the university. So it benefits both. So there's no conflict there. So it's kind of a good deal for both and for me especially. So what I'm currently doing is like demanding fire safety analysis. These kind of analyses are needed when you want to do something unconventional. Normal shipbuilding, if you are talking naval ships, you need to follow rules just as long as your customer tells you need to follow rules. But when we are talking commercial ships, cruise ships, there is rules for everything, and you need to follow the rules. You have the classification society and flag state making sure that you actually follow those rules. And SOLAS, Safety of Life at Sea, is the marine Bible, and everything starts from there, and everything it says needs to be fulfilled. That it says a lot of other documents then need to be followed as well. But when you want to break the rules, you want to do something that the rules do not allow. From a fire safety perspective, there's basically 3 possibilities for that. You can apply for equivalency or exemption, and the most rigorous process is alternative design and arrangement. And these are the things that I now mainly work on. And basically what these are, I'm gonna keep more detailed technical presentation on fire safety design of cruise ships and on the alternative designs especially later on, probably next month. So if that is of interest to you, please tune back in. But these are what I basically deal with. And in most cases, it's some sort of engineering analysis and some expert judgments, etc., that needs to be used in order to convince the classification society and the flag state that our approach is actually safe, that we are not trying to do anything that's gonna put the operator or passengers or environment or anything in danger. And typical analyses that are done on pretty much every ship are large main vertical zones. So basically there's some maximum dimensions that one main vertical zone can have. And all the cruise ships, they are big, and owners want a lot of attractions and other stuff in there. And that always drives the design into situation that we have larger main vertical zones than what the rules allow. So we need to make fire safety studies of those. Same goes for larger than permitted openings in main fire bulkheads. And then there are some other ad hoc specific issues. For example, I need to do some random fire simulation for United States Coastal Guard because they were worried that our passengers' shoes are gonna burn into deck if there's a fire underneath the current deck. So I had 2 days to do that while the United States Coast Guard was present at our shipyard, and I needed to make a report out of that. But here you can see a picture of one fire simulation that I did for large main vertical zones. And below you can see the visibility development inside the area. So basically, there is no the scale now, but it basically shows just how far you can see inside the compartment at a certain height. The visibility tends to be the first criteria that says your passengers are endangered in a fire in larger spaces. And then my PhD. The subject is cost-benefit analysis of fire safety systems on board passenger ships. So you can see how that ties into what I do at work. And in reality, what that means is what is the human life value on board a cruise ship. There is a lot of ethical and moral opinions and thoughts around the subject. Many say that it shouldn't and couldn't be calculated at all. And I'm not saying that there's going to be a single numerical value for it or something like that. It's going to be a spectrum. There's going to be a lot of different aspects that affect it. But I say it's actually morally beneficial to calculate some value because when you have value, you can do real cost benefit analysis, which then favors the most appropriate and effective methods to save lives. So basically, in long run, it should result in better outcome. And the topic has been studied quite a lot on land-based applications, for example, on traffic and on some building-related stuff and airplanes, but it has never been studied on context of passenger ships, at least not that I know of. And my hypothesis is that the value is going to be a bit higher for passengers on passenger ships and the crew as well. And this is just because if you have a skyscraper or tall story building and those collapse and you kill 500 or 1,000 people in that, it's going to be a tragedy. It's going to be in the news and it's going to be awful. But that's not going to stop the surrounding buildings from use. They're going to be full of people still. And it's going to probably reflect some regulatory exchanges, changes, and so on. But if you sink a ship and kill 500 to 1,000 people, you can be sure that it's really difficult to sell tickets for other ships for weeks or months or even years. And one aspect is that you don't want to own a brand of ships, the ship brand that killed 500,000 people at once. You're going to have, even by yourself, really hard time selling tickets. So this is just a hypothesis, and I think that would make the value of human life in cost-benefit analysis a bit higher on board passenger ships than in land-based applications. I started this on beginning of 21. I'm doing it part-time only. So I have not done a lot yet. I went to the very beginning, studied some credits so far, and familiarized myself with the subject some, and that's pretty much it. I'm starting to get the first journal article together soon. And the final steps of getting here in reality. I read on our university's homepage from somewhere that international exchange is strongly advised for all PhD students. And I asked my professor about it. He basically just asked where I would like to go. I read something about Michigan and I was already interested to visit US. My professor knows Kevin knows him, so the rest is history. We applied some funding, we got some funding, got lucky with the visa because COVID, there was absolutely no available visa interview times. And traditionally, you always need to have interview in order to apply for the visa. But due to some presidential declaration issued last year, research scholars do not need to attend the interview. So I was lucky and got the visa in time, booked a flight, and now I'm here. So that's it. Thank you very much. If you have any questions now or later, feel free. There.
So in Finland, is it required for only 1 year of Army service after high school? Or is there like a certain amount or school or anything like that?
Basically in Finland, you can go to the army between age of 18 and 26. You have to go during that time period, and it changed recently. They shortened the longer period you could stay there, but when I attended, you could stay 6 months, 9 months, or a year. And it basically depended on what you did there, how long you would stay. Any others? There's one.
What makes the shipyard you were working at more advanced than any others?
Meyer Turku.
Right. Why is that one so unique and special?
Basically, one thing that's going for us is hydrodynamic expertise. And that shows in that our cruise ships are the most fuel efficient around. And that's been one of the selling points. And another thing is that we are, like, historically, say, large main vertical zones and new and innovative technology on board. Our ships have had them always first. And like, I haven't been working there so long that I would have been part of that. But we have been like the early adapters of everything, pretty much. For example, the alternative design and assessments, the first ones that were really used, it's quite a new thing, but first time it was really used was on the Oasis class of ships. And the first Oasis class ship was the world's biggest cruise ship, 360 something meters long, 40 something meters wide, and 60 or 70 something meters tall. So huge ships. That was delivered from our shipyard in 2009, and the alternative design methodology was first time used in real applications with that ship, for example. And one thing that's separated us from many other shipyards is that we are a bit more expensive than the others, but we have been able to cater to the needs of the owners. And we have been able to be really flexible in the design and modification of the designs. It's not uncommon for us to actually make structural changes on ships that are already floating. So that's stuff that many others don't do. Did I answer the question? Thank you.
So I know you said you did a bit of work on ice-breaking technology, some exhaust system arrangements, and then now fire safety. Are there any other parts of the industry that you've been interested in that you might want to try and get into?
Currently, I am not that interested. Like, I'm really into what I do. That's cool now. But like, the engine stuff was interesting, what I did in Wärtsilä. It was really interesting, but at the end, I liked the variety that the ship design actually enables more. And that again depends really much on your role on the shipyard or at smaller office of what you do. You can be really specialized in one certain thing at the shipyard as well. But you can also, if you get into concept design, for example, then you're dealing with everything. Or one thing that I was interested at one point that I never tried of was like project management side. But yeah. Looks kind of quiet. I don't know how this goes, but from my perspective, you're all free to go.
Thank you.
Thank you.
Thank you very much.